This is video 2 for the 2011 Form A test, and we're going to start this video by fixing the last one. Right after I stopped making the last video, I realized my mistake, and that is when I plugged in the function, excuse me, when I plugged in the function right here in my calculator, the parentheses opened up for sine, and they also opened up for e. And I only had one closed parenthesis, so my +1 was actually inside of sine. So as soon as I fixed that on my calculator, I got the correct answer, which was 1.94938, and that was correct on the answer key. And then in part C, I would get the same, I'd get the right answer, math 9. Let's see, y variables, oh, not yet. I gotta go back to math, absolute value of y values, close, alright, comma, x comma 0 comma 6, enter, and wait. And wait, and I assume it's doing something. There it is, 12.573. And I don't recall the correct answer on that one, but I'm sure that that's got to be it. Okay, so moving on to question 2. Okay, so this is a question that talks about a pot of tea cooling, and again we have a chart here, and the data they've given us is the degrees Celsius. So this is the top of the function. It isn't the derivative. It's not a rate of change. If this was, position velocity, then we're looking at a position information more or less. Okay, so use the data in the table to approximate the rate at which the t is changing at time 3.5. So the rate of change is the slope at a point, but we don't have an equation, we just have data, so we're going to approximate. 3.5 is halfway between 2 and 5, so I'm just going to, I'll just write it right over here, solve A. I'm just going to do h of 5 minus h of 2 over 5 minus 2, which is going to be 52 minus 60 over 3, which is -8 thirds. Units would be degrees Celsius per minute. And so just use the data to approximate the rate. Don't explain it, just show the computations done. Part B, using correct units, explain what that means. The 1 over 10 from 0 to 10 of h of t dt in the context of the problem, and then see if you can figure out what the area actually is. So this simply is telling us to add up all the temperatures and then divide it by 10. So this would represent, represents the average rate of change. That's not true at all. Sorry, brain went elsewhere. The average temperature, because that's what we're adding up, is the temperatures in degrees Celsius from time equals 0 to time equals 10 minutes. Average temperature, we might want to say of the T, just to throw the context of the problem in here. Okay, that's pretty simple. And then they actually want us to use trapezoids to find the actual answer. The complication of this problem is our gaps between the intervals are not the same. So our heights are not the same. So we can't just factor everything out. So I just gotta basically take half of the base, which would be, well, sorry, the height, which would be 2 times base 1 plus base 2 plus half. Next one is a height of 3, 5 minus 2. And we've got base 1 and base 2 is 60 and 52. Plus a half of 4, 52 and 44. Plus half of 1, 44 plus 43. And this would be the total, and then I would have to divide it by 10. So I'll get 1/10 of that, which is going to be, let's see, those cancel, so we're going to have again, we have some riveting television as I do some calculations. And it's taking longer than I thought. Let's see, 96 plus, what's that, 87? Alright, that was quick. I probably made a mistake. 529.5. So the average then would be 1/10 of that. So 52.9 degrees Celsius. Let's see if that makes sense. Yeah, it could be definitely fit within that range. If I had more time on the test, you know, if I was done with the thing, I would probably come back and just double check my math on that, since I've already made one calculated mistake on this test. Okay, moving on. Part C. Evaluate 0 to 10 of h prime of t. Alright, so the key to answering this question is realizing that they've given us the derivative in the integrand, and so when I take the antiderivative of h prime, I just get h. Then they want me to evaluate from 0 to 10, giving me h of 10 minus h of 0. So I go to my chart and I get 43 minus 0, 66. And let's see, what's that going to be? 23. So equals negative 23. And what would the units be? I've added up all of the h primes, and so that's going to get me degrees Celsius, because ultimately I'm plugging into the function h, which is in degrees Celsius. And then once again, what does it mean? This would simply be the change in temperature. So the change in temperature, or we could even just talk about it. We could say the T in the pot lost 23 degrees Celsius in the first 10 minutes, in the 10-minute time period, something like that. Again, not very technical, but should get the message across. Alright, let's move on to part D. Alright, so at time 0 we had some biscuits at 100 degrees and they were taken out of the oven. The biscuit temperature can be modeled by this. The change in the biscuit temperature can be modeled by this. So they want us to find out how much cooler are the biscuits than the tea. So what I need to know is how warm are the biscuits. So at time 0 they were 100 degrees and then the temperature did something. So I'm going to add, because I believe the way they have the temperature set up, it's going to come out as a negative number if I lose. So I don't want to put a subtraction there and have it actually end up adding. So, 0 to 10 of b prime of t dt, and this will be how warm the biscuits are at that time. Alright, so I got to type that in my calculator. Alright, negative 13 point, where'd it go? 84 e to the negative 0.173 t power. Okay, so now I'm going to add them all up. Math 9, variables, y, function y1, x, comma 0, comma 10. Sure enough, it's a negative number. I'm going to add 100 to that. I get an answer of 34.182 degrees Celsius. So the question then asks, what's the difference in the temperature? So, not much. So this is the biscuit temperature. And the T was 40 degrees. My memory's bad. Let's make sure I'm right. 43 degrees. 43 degrees. Sorry about that. And so the difference between those, 8 point, so a difference of 8.817 degrees Celsius cooler than the T. Okay, let's see how we did. That's part D. Alright. So the derivative at 3.5 can be approximated by finding the slope of the points around it. Negative 2.667, I think that's what we got. 1 point for the answer. This is the average temperature of the T in degrees Celsius over the 10 minutes. That's pretty much what we put. 52.95. Let's see how my math was. Yeah, I don't know why I didn't put the second decimal there. And negative 23 is what we got. The temperature drops 23 degrees from time 0 to time 10. We said the temperature of the T lost 23 degrees. That seems good. And then 8.81 degrees cooler. And that's what we got. Okay, this is the end of video 2.